In this video, we're going to be talking about example problems from 1.2, where we start to talk about matrices, and we'll talk specifically about Gaussian and Gauss-Jordan elimination. Let's start with number 5 from the textbook. It asks us to identify the size of this matrix. So to identify the size of the matrix, we're going to count how many rows it has. 1, 2, 3, 4. And we use an X that is read by. And then how many columns? 1, 2, 3, 4, 5. So this is a 4 by 5 matrix. Let's move on to number 7 now. It asks us to identify the elementary row operation or operations that are happening. Our original matrix is 3, -1, -4, -4, 3, 7, and we're doing something to it to get 3, -1, -4, 5, 0, -5. I noticed that row 1 hasn't changed, so I'm definitely producing a new row 2, and I'm adding a multiple of row 1 to row 2 to produce a new row 2. So adding something to row 2 to produce a new row 2. So I added, let's see, 9. So that's going to be 3 times row 1. Let's see, -3 plus 3 is 0. -12 plus 7 is -5. So that checks out. 3 times row 1 added to row 2. That's right. Okay, let's go ahead and look at number 9. Same kind of question. 0, -1, -7, 7, then -1, 5, -8, 7, 3, -2, 1, 2. And I'm going to tell you there's actually 2 steps involved to this. So there's an intermediate step before we get to -1, 5, -8, 7, 0, -1, -7, 7, 0, 13, -23, 23. So the first thing that I see that we've done is we've swapped row 1 and row 2. So that's my first step. And then my second step is I've changed row 3. I've taken 3 times my new row 1 plus row 3 to produce a new row 3. And that's that. Let's go ahead and move on to number 17, which is 1, 2, 0, 1, 4, 0, 1, 2, 1, 3, 0, 0, 1, 2, 1, 0, 0, 0, 1, 4. And my instructions tell me that this is an augmented matrix, meaning that this last column over here is really after an equal sign that I'm not seeing, but that's my solutions part of my matrix. And I want to solve the system of linear equations that's represented by that. So let's go ahead and just use Gaussian elimination here. And we'll say that this is column 4. So x4 equals 4x3 plus 2x4 is equal to 1. So that makes the equation x3 plus 8 equals 1. x3 equals -7. Then we have the equation x2 plus 2x3 plus x4 equals 3. So that becomes x2 plus -14. So that's -14 plus 4 is equal to 3. That's x2 equals to 13. And then we have x1 plus 2, x2 plus x4 is equal to 4. So that's x1 plus 26 plus 4 is equal to 4. So that is x1 is equal to 4 minus 30. That's a -26. So I have a solution of x1 equals -26, x2 equals to 13, x3 is equal to -7, x4 is equal to 4. I could write that as an n tuple, -26, 13, -7, 4 as well. Let's go ahead now and look at number 21, which asks us about row echelon form. For something to be in row echelon form, every the first non-zero, all rows of zeros must be at the bottom. Every entry, the first non-zero entry in the row must be a 1, and all of the ones must be to the such that the one that is furthest to the left is above the one that's next furthest to the left on down to the one that occurs furthest to the right, so that they're standing in line from highest highest in rank, you could say, to lowest. That's what echelon is standing in order like that. Shouldn't use the word rank, that means something else later. But so 21, let's just take a look at this and see if this one is in row echelon form or not. It's going to be very easy to see that it is not in row echelon form, because we do not have our first non-zero entries in each row to be 1. They are going in order here, though. So if I had gotten this to where I multiplied through by -1/2 here, or multiplied through by -1 here, and by 1/2 here, it would be in row echelon form. I just haven't quite gotten there yet, but let's go ahead and jump on down to number 29, which is a system of equations that we want to solve. And we have -3x plus 5y is equal to -22. 3x plus 4y is equal to 4. And 4x minus 8y is equal to 32. So I'm just going to put this into matrix form just to help me keep track of everything and not have to write the letters all the time. So this is -3, 5, and then I'm going to augment that -22, 3, 4, 4, 4, -8, 32. First thing that I want to do is I want to try to get a 1 in the first column. So the easiest way for me to get a 1 is 4 minus 3. So I'm going to add row 1 to row 3 to produce a new row 3. Then I want to put that in row 1. So I'm going to swap row 1 with row 3. 1, -3, 10, -3, 5, -22, 3, 4, 4. So now I want to get zeros beneath. So I'm going to use row 2 and row 3 to add to give me a new row 3. It's going to give me 0, 9, -18, 3, 4, 4, 1, -3, 10. Okay, so now we're going to eliminate that 3 in row 2 by taking -3 row 1 plus row 2 to make a new row 2. And that's going to give us 1, -3, 10, 0. 9 plus 4 is 13. And then this is -30 plus 4 is -26. 0, 1, and -2. Going to, I already have a, getting ahead of myself here when I wrote that. Doesn't matter which of those I get. I want to get a 1 in the second row. So let's go ahead and use the second row that I already have there. Take 1/13 of row 2 to make a new row 2. That's 1, -3, 10, 0, 1, -2, 0, 9, -18. And we want to take -9 times row 2 plus row 3 to produce a new row 3 is going to give us 1, -3, 10, 0, 1, -2, 0, and this will end up being 0, 0. So that equation kind of drops out. It's not important to me. So this is really the matrix 1, -3, 10, 0, 1, -2 now. My equation my system was what was called overdetermined. I had an extra equation that I didn't really need in there. This is already set up for row echelon form right now, but I'm one step away from reduced row echelon form where I can get a 0 above this 1. So I'm going to go ahead and just take that step. 3 row 2 plus row 1 makes a new row 1. And I get that this is 1, 0, and then 10 minus 6 is 4, 0, 1, -2, and I get x is equal to 4, y is equal to -2, and I could write that as the ordered pair for -2 as my solution. Let's go ahead and look now at number 33. By the way, the steps that I'm taking are not the only steps that you can take, but I am doing correct steps that follow the elementary row operations that you have learned about that are legal for you to take, whether you're dealing with systems of equations or matrices. You can do those elementary operations on each equation set up as a system, or on each row which represents an equation set up as a matrix. So number 33 asks us to find the solution to this system. I'm again going to write this in matrix form. The first thing that I want to do is use that 2 to get zeros underneath it. Since 4 and 8 are both multiples of 2, I'm going to go ahead and do that at the same time. That negative 2 times row 1 plus row 2 will produce a new row 2, and negative 4 times row 1 plus row 3 will produce a new row 3, leaving row 1 alone. This is 0, and then my negative 3, and then negative 5, and then negative 7, and then 0, negative 9, 3, negative 2. So 2, 0, 3, 3, 0, negative 3. It should be 1. So we have 2, negative 2 times 3 is negative 6 plus 7 is 1. And that is negative 6 plus 5 is negative 1. There we go. And now we want to use that negative 3 to get a 0 there. So I'm going to take negative 3 times row 2 plus row 3 to produce a new row 3. Negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times negative 1 is 3, plus negative 2 is 1. This last equation here says 0 equals 1, which is false, which means that there's going to be no solution to this equation because one of those equations is parallel to the other. There's no point of intersection of all three of them, is what that's telling me. So there's no solution there. Let's go ahead and I guess since it's 3D, they could also be skew, not necessarily parallel, but two of those don't ever intersect, I guess should be what I was saying. So there's no way that all three of them intersect at a single point. 43 says that we have a homogeneous system here. And if you have taken differential equations, you'll be familiar with the word homogeneous. It just means that everything is equal to 0, and they're not writing that here. So really what this is saying is this times x1, x2, x3 is equal to 0, 0, 0. They didn't write all that part. They just wrote this first part, but that's what they mean. So this could be condensed into the form of 1, 0, 0, the 0 over there, 0, 1, 1, 0, 0, 0, 0, 0. That would mean the same thing to me. Now, what I'm looking for is this is more variables than it are here than are defined. I only see a definition for x1 and x2. I don't see a 1 here in row echelon form for x3. That would need to be in this spot. It's not there. I see the equation 0 equals 0. So that means that x3 needs to be a parameter t. And that tells me that everywhere that I see an x3, I need to put a t in its place. So x2 plus x3, which is t, is equal to 0, which tells me that x2 is equal to negative t, and x1 is just equal to 0 here. So my solution here, x1 equals 0, x2 is equal to negative t, x3 is equal to t, and I could write that n tuple, and that means that there's infinitely many solutions to this. Just pick any real number for t and generate a solution set there from that. So I could, for instance, have 0, 0, 0, 0, negative 1, 1, 0, negative 1 half, 1 half, 0, negative root 3, root 3, 0, negative cube root of 7, positive cube root of 7. I could have 0, 2, negative 2, if t was negative 2. All these types of different ordered triplets that are going to be on my solution, or in my solution set on my line that I'm going to have there for my solution. So can't really call this one a line that has the solution coming up here, or plane, or whatever it's going to be, because I am in 4 dimensions. But let's look at number 45. It says that I have 1, 0, 0, 1, 0, 0, 1, 0, and 0, 0, 0, 0. And again, they tell me that it's homogeneous. They just give me this much, which I know tells me that I have x1, x2, x3 equals 0, 0, 0. So that's going to mean that I have 1, 0, 0, 1. I'm going to augment this 0, 0, 1, 0, 0, 0, 0, 0. So looking at each column, I don't see a 1 in column 2, meaning that x2 needs to be a parameter. I also don't see a 1 for column 4. There's a 1 here, but there's not a 1 down here that leads column 4. So x4 is t, x2 is s, and so we have x1 plus x4 equals 0, which means x1 is equal to negative t, and we have x3 is given to us as being 0, since there's that equation x3 equals 0. So I have negative t s 0 t for my n tuple there. And that is it for this video. We'll come back next time and talk about some example problems from section 2.1. Section 2.1 is operations with matrices. So I'll see you for the next video.